Hi everyone, my name is Mokhamed Ranne and I'm a master's student in the Adronov group. And one of the things that we do in our lab is work with carbon nanotubes and polymers and then incorporate them with each other to make unique materials with exceptional properties. Some of these properties include sensitivity to different environments, such as carbon dioxide. It includes changing the conductivity of the carbon nanotubes from what they would normally be. We can increase it or decrease it. And finally, another one of the key things that we've been doing is incorporating the polymers to separate out semiconducting carbon nanotubes from metallic ones. In this video, I'll show you how we prepare our carbon nanotube sample dispersed in polymer solution and some of the characterization methods that we employ in our lab. So before I show you how we make our nanotube solution, here's an example of just nanotubes by themselves in solution. And the reason we want to incorporate polymers into these is because when the nanotubes are in solution by themselves, they're completely insoluble. As you can see here, I'll shake it around and they just sink to the bottom and don't dissolve at all. But as you will see, when you add polymer into the solution, they become soluble. Okay, so the way we incorporate our polymer onto the nanotube is by dissolving our polymer in solvent, and then, as you can see here, we'll add the solvent in, and it dissolves. And you can see the bits of carbon nanotube in there waiting. Now, it hasn't fully dissolved yet, but when we take it and move it over to the sonicator, that it'll sort of disperse right away. Right, now that our carbon nanotubes have been properly dispersed in our polymer solution, we've moved it over from a vial into a centrifuge tube to move into our centrifuge. So here we go. We've counterbalanced it already, got it all set up. And we're going to centrifuge it for half an hour at 8,346 gravity units. So one of the characterization methods we use on our polymer-wrapped carbon nanotubes is atomic force microscopy, or AFM for short. So what this does is it gives us a physical scan of our nanotubes and lets us see what's really going on and what they look like. So if you look at the screen right here, you can see the nanotubes and little bits of polymer on them as well. And then just right over there, we actually have our Raman instrument as well. And this is another characterization that we use to tell whether our nanotubes are semiconducting or metallic. So another one of our key techniques to characterizing our nanotube samples is the fluorimeter. And what it does is it shows us the fluorescence of our samples and where they spike up. So if you look at the spectrum here, you can see the different areas each represent a different sample of nanotube or polymer wrapped nanotube that is fluorescent. And so the fact that you only see one large signal here is a good thing because it shows that we have a really uniform sample and it makes one type of material. So I hope you guys enjoyed seeing how we prepare our carbon nanotube samples and some of the characterization methods that we employ. Thank you all for watching, and I hope you guys have a nice day.